Concrete is the most abundant man-made material on the planet. And cement is the main ingredient in concrete, but accounts for 7% of the world's CO2 emissions. And is one of the largest contributors to carbon emissions in the built environment.
There's a movement in the world to reduce carbon in the atmosphere, and people that are building want to have ability to do that.
How does CarbonCure fit into this picture of reducing carbon? CarbonCure has developed a technology that injects CO2 into the concrete during mixing, just like an admixture. Once introduced into the concrete, a chemical reaction takes place where the CO2 is converted into a mineral and permanently embedded in the concrete, even if the building is destroyed later on.
On average, every load of concrete that we're shipping out that's been treated with CarbonCure is reducing the CO2 emissions in the atmosphere by 200 pounds. It's the same product, it's just with the enhanced benefit of taking carbon out of the atmosphere.
So this process not only improves the strength of the concrete, but allows us to reduce our cement content, that material with the highest carbon impact, by about 5% without impacting any fresh or hard properties. So ultimately, it's the same concrete being delivered to the job site, just with a reduced carbon footprint.
And if we can provide that with the same quality concrete that we always do, then it's a total win-win for everybody. We're able to reduce the amount of cement that we're using to make the concrete. The CarbonCure technology allows us to not sacrifice on the quality of the concrete because it's providing some additional strength. So we're net neutral on the concrete performance with the added benefit of taking carbon out of our atmosphere.
CarbonCure is on a mission to reduce 500 million tons of CO2 emissions annually. And that's the equivalent of taking 100 million cars off the road every single year. We are really excited about the opportunity to partner with more producers to help us achieve our mission of reducing carbon.